Hello students, in this video we are going to work on some examples that how we can find out the solution of a homogeneous system of linear equations. But before that, a point which we are going to keep in our mind, that let us say we have a homogeneous system of linear equation represented in the form of matrix as Ax is equals to O, where A is the coefficient matrix, X is the variable matrix, and it is a system of, let's say, m equations and n variables. इस सिस्टम में हमारे पास m इक्वेशंस होंगी और n क्या होंगे, वेरिएबल्स होंगे. नाउ इफ वी सी x is equals to 0 is trivial solution of equation 1. Trivial means, we can say, trivial means obvious solution of equation number 1, because x is equals to 0 is going to satisfy this equation. वट एवर इज़ द केस हियर, जिस भी तरह का हमें सिस्टम दे रखा हो, जो एक्स इज इक्वल्स टू ज़ीरो है वो उसका सोल्यूशन होने ही वाला है. इट मीन्स द सिस्टम वन इज ऑलवेज consistent. Thus, what point we get here, that a homogeneous system of linear equation can never be inconsistent, because it always has a trivial solution which is x is equals to 0. जो ज़ीरो सोल्यूशन है वो इसका हमेशा सोल्यूशन होगा ही होगा. इट मीन्स जो हमारा होमोजीनियस सिस्टम है वो कभी भी इनकन्सिस्टेंट नहीं हो सकता है. And if it is always consistent, but still two possibilities are here. One possibility is that it is having unique solution, and the second possibility is that it can have infinitely many solutions. Now we will work on some examples to see how we are going to solve a system of linear equations. Now let's start with example 1. The system of linear equation is given to us as x plus 2y plus 3z is equals to 0, 3x plus 4y plus 4z is equals to 0, 7x plus 10y plus 12z equals to 0. As you can see, this is a homogeneous system of linear equation. Now we are going to solve it. Let's rewrite this above set of equations in the form of a matrix. Ax is equals to 0, where A is our coefficient matrix 1, 2, 3, 3, 4, 4, 7, 10 and 12. The variables here listed are x, y and z equals to the column vector 0. Now what we will do, we will transform this matrix A into the echelon form by using elementary operations. And keep one point in your mind, that when we apply elementary operations on a system of linear equation, it's not going to affect, it does not affect the solution of सिस्टम ऑफ लीनियर इक्वेशंस. अगर हम एलिमेंट्री ऑपरेशंस अप्लाई करेंगे तो हमारा जो सोल्यूशन है इस सिस्टम ऑफ इक्वेशंस का वो अल्टर नहीं होने वाला है. मीन्स जो सोल्यूशन हमें यहाँ से डायरेक्ट मिलना था इन इक्वेशंस को सॉल्व करके, वो सेम सोल्यूशन हमें कैसे मिल जाएगा अगर हम इस मैट्रिक्स को किस में कन्वर्ट कर दें, एक्लन फॉर्म में, विद द हेल्प ऑफ एलिमेंट्री ऑपरेशंस. नाउ आवर प्राइम target is to convert this matrix A into the echelon form. So to convert this into echelon form, the first operation we will apply here is on R2, R2 minus 3R1, and then on R3 as R3 minus 7R1. Let's apply these operations on the above set. What we will get here, now the system is equivalent to, the system will become 1, 2, 3, 0, minus 2, minus 5, 0, minus 4, minus 9, xyz equals to 0, 0 and 0. Now the next target is to convert this minus 4 to 0. For that, let's apply the operation R3 minus 2 times of R2. Then the above system is equivalent to 0, minus 2, minus 5, 0, 0, 1, xyz and 0 vector. Now we can see this is the desired echelon form of our matrix A. Now what we will do? We will do the now reverse step. Now we will convert this matrix into again as a system of linear equations. So which gives us x plus 2y plus 3z is equals to 0, minus 2y minus 5z is equals to 0, and z is equals to 0. Three equations are here. Now whatever is going to be solution of these three equations, that will be the solution of our given system of equations. जो हमें क्वेश्चन में इक्वेशंस दे रखी थी उनका जो सॉल्यूशन था वो सेम होगा जो सॉल्यूशन हम यहाँ से इन तीन इक्वेशंस का निकालेंगे. Now as you can see from equation 3 we already get z is equals to 0. Put this value, put value of z in equation number 2. When we put there, what we will get? We get y is equals to 0. Now we will put y is equals to 0 and z is equals to 0. Put y is equals to 0, z is equals to 0 in equation number 1, which gives us x is equals to 0. Thus the above system has only trivial solution, which is 0 solution, that is x0, y0 and z0. Now we will work on one more example in which we will see how a system is going to have infinite set of solutions, infinite number of solutions. For that, let us consider an example. 4x plus 2y plus z plus 3w is equals to 0. 6x plus 3y plus 4z plus 7w is equals to 0. 2x plus y plus w is equals to 0. Now we have a system of three equations and four variables, and obviously it is the homogeneous one, and we are going to now find out its solution. For that, let's again write this system in the form of a matrix. When we are going to write that, we will get the coefficient matrix of order 3 cross 4, 4, 2, 1, 3, then 6, 3, 4, 7, 2, 1, 0, 1, along with the variables x, y, z and w equals to the 0 vector. Now again what we are going to do, we are going to transform this matrix into echelon form. Now let's apply the operation on R2. On R2 we are applying the operation 4 times of R2 minus 6 times of R1, and on the same time we will apply the operation on R3 as well, 2 times of R3 minus R1. Then the given system is equivalent to, so now this equations gives us 4, 2, 1, 3, 0, 0, 10, 10, 0, 0, minus 1, minus 1, x, y, z and w equals to the 0 vector. Now we will apply the operation on R3 as 10 times of R3 plus R2, which gives us 4, 2, 1, 3, 0, 0, 10 and 10, 0, 0 minus 10 plus 10, 0, 0. Then x, y, z and w equals to the 0 vector. Now this is the desired echelon form. Now let's convert again the system into the form of equations. So we get 4x plus 2y plus z plus 3w is equals to 0. From second we get 10y plus 10z is equals to 0. So we got only two equations, number 1 and number 2. Now from equation 2 we can say y is equals to minus z, and from equation 1 now let's calculate the value of, from equation 1 we will calculate the value of x. It can be written as, x can be written as minus 2y minus z minus 3w divided by this 4, that is minus 1 by 4. Substitute the value of y, which is minus z, so it's minus 2z minus z minus 3w. So we will get, sorry, plus z here now, because y is minus z and negative will give us positive value. So it is 1 by 4 z minus 3w. So the value of x is 1 by 4 times of z minus 3w. And let us choose z is equals to t1 and w is equals to t2, where both t1 and t2 are real numbers. Then it implies x is equals to 1 by 4 times t1 minus 3 times of t2, and y is equals to minus of t1. Thus we, as you can see, we get a set of infinite solutions where the solution are x is equals to 1 by 4 t1 minus 3 t2, y is equals to minus t1, z is equals to t1, and w is equals to t2, where both t1 and t2 are real numbers. Now whenever we are going to assign the value of t1 and t2 in these following set of constraints, we will get a different value of x, y, z and w every time. So we can say there are infinitely many solutions. For example, if I choose t1 to be 1 and t2 to be 2, then I will get a set of वेरिएबल विच इज़ गोइंग टू बी सोल्यूशन. फिर t1 t2 की वैल्यू हम चेंज कर देंगे, फिर हमें एक और नया सोल्यूशन मिल जाएगा. जैसे जैसे हम t1 t2 की वैल्यूज़ असाइन करते जाएंगे, हमें डिफरेंट डिफरेंट जो सोल्यूशंस है हमारे गिवन सिस्टम के वो मिलते जाएंगे. दिस वी कैन से above system has infinite number of solutions. So this was all about the solution of system of homogeneous equations. Do let me know if there are any doubts. Thank you.